Okay, this is the continuation of Series 1, Unit 3.
Okay, all right, so the next thing is to import the data from Excel to the work file created. So I go to my Excel, I have my data in Excel. This data covers 1960 to 2020. I have copied, then I go to Excel, click, paste. Okay, so I go to next, again, then I go to finish, and I click yes. So you can see that the data is successfully imported into the eView software. So I want to run a test. I want to use the GDP per capita to run the test, the unit root test of stationarity. So I double click, it has come up. So you can see that this is data on GDP per capita, and the data runs from 1960 to 2020, so it's complete. So the next thing is to go to first, as a rule of thumb, we're going to plot the graph of this data to see the trending pattern. To do that, we go to view, then go to graph, click, then click OK. You can see this is the graph of GDP per capita, and the graph is trending upward. That is, it has an upward trend, suggesting that the data is likely to be not to be stationary. That is, the data is non-stationary. The data contains unit root. So let's go to formal test using ADF. We'll go to view. This is the drop-down menu, and we go to unit root test. We'll go to standard and click. So this icon, you can see that here we have test type, and by default it is augmented Dikifula, which is the option we want to use. There are many other options, such as, okay, we have the Dikifula GLS, we have the Philip Perron, we have Kwiatkowski Phillips machine, we have the Elliott-Rothenberg stock point optimal, and we have NG Perron. However, we want to use the augmented Dikifula unit root test of stationarity. So here, these are tests for unit roots in. So here there are three options: level, first difference, and second difference. So we conduct the test at level, and the rule is, if the test is conducted at level and it is found to be stationary, there is no need to conduct the test again at first difference. If, however, the test is not stationary at level, then we conduct the same test at first difference. And most data that are not stationary at level appears to be stationary in first difference. So there are a few cases of data not being stationary at first difference, and then there will be difference again for the second time, and in most cases they are stationary at second difference. Okay, here we also have these are test equations to be included. We have intercept, we have trend and intercept, and we have none. We are going to carry out this test with intercept and see whether or not intercept is significant. If intercept is not significant, then if it is significant, it means that intercept is required in this analysis. Otherwise, it is not required. Then we also test for trend. If trend is significant, it is required. If it is not, then it is. So we are trying to say here is that if intercept is not significant, trend is not significant, then this option becomes the best option, okay, for the unit root test option. But here we're going to conduct with intercept first. Now we also have automatic lag selection, and here we have Schwartz information criteria. The maximum lag length of 10 is here in the box. However, this Schwartz information criteria is going to make is going to give us an automatic lag length that is optimal at the end of the. So let's click OK. Yeah, this is the unit root test result. So there are two. The result is in two sets. This is the first set, and of course this is the second set. If you check the second set, you realize that the test, the Schwartz information criteria selected a maximum lag length of 3, 1, 2, 3. That for first difference of the variables. That is why if you check here, look at here, you see that lag length is 3, and that is automatic based on SIC. All right. So now Here, check also, you realize that this is the intercept. Intercept is not significant in this test. Therefore, we do not require intercept with this variable. So we go back again. Now we're going to conduct the test with intercept and trend. I click standard unit. Okay. Every other options remain the same except here. And I click OK. So check again. You see that, look at intercept here. Intercept is still not significant at 5%, though statistically significant at 10%, but we're interested in 5%. So look at trend is also not significant. So that means the optimal test in this regard is the one that is without intercept and without trend. Therefore, none becomes the best option. Then we're going back again, and then we go to unit root, standard, and then we pick none. And I click. All right, so this is the test result. Now, here, what you have here is the T statistics, and these are the values of T. This T statistics rather is called tau statistics. Then this is the result of tau statistics. Yeah, that is the calculated tau statistics. Then this is 1%, 5%, and 10% critical values. These critical values are called Makinon values. So we compare the absolute value of the augmented Kifula T statistics with the 5% level. So the rule is that if the calculated value in absolute term is less than the critical value, we accept the null hypothesis. That is, we do not reject the null hypothesis, and as such, we conclude that the variable is not stationary. Why? Because the null hypothesis says that GDPC has unit root. That is, we are testing the null hypothesis that the variable contains unit root or that the variable is not stationary. So here, you can see that in absolute term, we have 0.297, and this is the 5% critical value. So the value of T statistics, the augmented equivalent tau statistics, is less than the Makinon critical value at 5%. Therefore, we accept the null hypothesis, or rather, we do not reject the null hypothesis, and as such, we conclude that the variable is not stationary at levels. So since the variable is not stationary at levels, the next thing is to conduct the same test now at first difference. So we go back to view, standard, the unit root, standard, and click. Then we change this option to first difference and we click. Wow, you see that now the augmented equivalence is minus 0.4940814, and look at the probability value is 000, suggesting that it's significant. So the calculated value of tau statistics is now greater than the critical or Makinon value at 5%. Therefore, we say that though the variable is not stationary at level, because the calculated T value is less than the critical value at 5%, but now on first differencing, the variable becomes stationary because the calculated T or tau statistics is now greater than 5% critical value. Hence, the variable, this variable GDP-PC is said to be integrated of order 1. Thank you very much. Don't forget to like, share, and subscribe. Thank you once again.